Hi everyone. Before we begin, I want to let you know that this video has a contest or a challenge within it. Throughout the video, a little cat will appear in various positions. It's your job to comment below the amount of times the cat appears and give me an example of something you learned that you couldn't help but share with others. For example, I just learned that for the final season of Star Wars: The Clone Wars, they actually recorded Darth Maul's fight scene in live action with Ray Park, the original person who portrayed Darth Maul. They used motion capture technology to transfer his live action performance into a cartoon animation. On Friday, May 8th, I will gather all the comments with the correct answer and draw, at random, a winner. The winner will be able to choose a character or scenario for me to use as an example in my next video. This character could be fictional, non-fictional, or it could even be yourself. I will animate it and everything. On top of that, I will also include the interesting thing you learned, sharing and explaining it in detail for everyone. Remember, in order to win, you must be subscribed to the channel. With that being said, let's start the lesson. In our last video, we looked extensively at motion, both uniform and accelerated. The question of why objects exhibit uniform or accelerated motion puzzled philosophers and scientists for centuries. It wasn't until the 17th century that Isaac Newton described the important relationship between forces and motion. Imagine a dodgeball lying still on the gym floor. The reason it's not moving isn't because there isn't any force acting on it. On the contrary, it's because forces are acting on it equally in every direction. Recall that a force is defined as a push or a pull on an object, and that force is measured in newtons, like Isaac Newton. Get it? The resting ball will only move when the force being applied to it is unbalanced or unequal. With an unbalanced force, the force acting in one direction is greater than the force acting in the opposite direction. Now, if a person rolls another ball into that stationary ball, he or she will be using energy to apply that force. The energy is transferred from the person to the ball through the ball they just rolled. This results in a change in motion to the last ball. Once an object is in motion, it tends to remain in motion, moving at a constant speed in a straight line. However, if an unbalanced force is applied to the moving object, it will speed up or slow down. If an unbalanced force is applied in the same direction as an object's motion, the object will speed up because of the additional force applied in that direction. If another force, such as wind, is applied in the opposite direction of the object's motion, the object will slow down. You can see this at work when you go for a run or a bike ride during a windy day. To fight against the wind, you need to put more effort or force in the direction you are traveling in order to maintain the same speed. In the absence of any outside forces, such as resistive force, all objects tend to maintain a uniform motion or stay at rest. An object in motion will stay in motion and no energy will be required to maintain that motion. The two examples above illustrate that if an unbalanced force is applied to an object, energy is transferred to that object. This causes the change in motion. In this next example, Oi is the name of my cat for those of you who don't know, and myself are recreating the opening scene from The Lion King. I am lifting the cat above my head. For this to occur, I have to apply a force in the upward direction that is greater than the force of Earth's gravity. In this scenario, I did the lifting, meaning I did the work, and the energy was transferred from me to the cat. This energy transfer results in the cat's position to change relative to the Earth. Force can be calculated by using the formula force equals mass times acceleration, or F equals ma. Now, similar to speed and acceleration, people tend to use mass and weight interchangeably. But remember, this is incorrect. Mass is a measurement of the amount of matter something contains, while weight is the measurement of the pull of gravity acting on that matter or the object. For example, if you travel to the moon, your weight will decrease due to the lower amount of gravity acting on you. But your mass does not change. Using the force equation, we can figure out how many newtons of force is required to move objects at particular speeds. For example, if a truck has a mass of 1,500 kilograms and we want to accelerate it to 2.50 meters per second squared, what force do we need to produce? Well, looking at our variables, we have the mass of the truck, which is 1,500 kilograms, and the desired acceleration, which is 2.5 meters per second squared. We plug those into the formula like this. Force equals 1,500 kilograms times 2.5 meters per second squared. This gives us an answer of 3,750 newtons of force. We can also arrange this formula to solve for the other two variables. In this next example, we try to find the mass of a crate located on planet Earth that has a force of 450 newtons. What we do here is we fill in the variables as normal, then rearrange the equation like so. We move the m, which stands for mass, to the left of the equal sign. Then we throw over the 450 newtons over to the right. From here, we divide acceleration by the force to get the mass. In this case, it is 450 newtons divided by 9.81 meters per second squared, and that gives us an answer of 45.87 kilograms. So now that we have an idea of how to calculate force, mass, and acceleration, let's do a more complex example, combining what we learned last lesson about velocity and today. Suppose Oi, my cat, did not like playing Lion King and escaped my grasp and ran away. In 5.0 seconds, this little furball goes from standing still to a speed of 20 meters per second. Now we want to find out the force required for this cat to do this. First, we have to remember the information required to solve this. In order to calculate force, we need to know both the acceleration of the object and the mass of the object. Now, in this example, we know the cat weighs approximately 5 kilograms. However, we do not know his acceleration. We only know the initial speed is 0 and the final speed is 20 meters per second. We also know that it takes him 5 seconds to reach that speed. Now, some of you probably already realized that we actually have all the information needed to calculate the acceleration. Recall last lesson where we learned that acceleration equals final velocity minus initial velocity divided by the change in time. Hence, the equation for this example would look like this. 20 meters per second minus 0 meters per second divided by 5. If we do those calculations, we get an acceleration of 4.0 meters per second or 4.0 meters per second squared. Now that we have our acceleration, we simply punch it into the force formula. So force equals mass times acceleration. Now we get an answer of 20 newtons. Whenever a force moves an object through a distance, work is being done. Let's break this down visually. Work equals force times distance the object traveled. This can be shortened by writing work equals FD. Now in physics, units are everything. So far we have learned that force is measured in newtons, mass is measured in kilograms, distance is measured in meters or kilometers, velocity is measured in meters per second, and acceleration is measured in meters per second squared. Work is no different. The unit for work is what we call a joule. A joule is a unit we use to describe energy. More specifically, 1 joule is the amount of energy used when displacing a force of 1 newton by 1 meter. So now that you understand the concept of work, let's take a look at some examples where we calculate work being done in a fun way. In this example, Goku, who is my favorite anime character, is shooting an energy beam at a huge rock. This makes the rock move 25.2 meters away from him. The energy beam is producing a force of 15,000 newtons. How much work was done by the energy beam? Well, the formula we will use is work equals force times distance. Punching in our variables, we get work equals 15,000 newtons times 25.2 meters. This gives us an answer of 378,000 joules. Now, if we write that out in scientific notation, it is 3.78 times 10 to the power of 5 joules. To summarize, if an object has energy, then the object can do work by transferring that energy to another object. This leads to the definition of energy. Energy is the ability to do work. Work and energy are actually the same thing when you think about it. If an object does work on another object, then that object doing the work loses energy, and the object that has the work done to it gains the energy. And since work and energy are the same, they use the same units. They both use joules. The idea of energy eluded early scientists because energy is a very difficult concept to define. Ask what the definition of energy is and what comes to mind. For me, energy reminds me of electricity and Dragon Ball Z videos. Energy can be exemplified in very diverse ways, which makes it frustrating to fully grasp the concept. For example, the sun's energy causes snow to melt in the spring. So that gives you one perspective of what energy is. But we also know that a person who has just run a marathon has also used up a lot of energy. See how these concepts can be confusing? The truth is, we only see the evidence of energy when something is done. So it's not surprising that the development of the concept of energy went hand to hand with the development of technologies that use energy. It was only through observing the change in these technologies that scientists started to get a clear picture of the concept of energy. As understanding increased, scientists realized that energy could be observed and harnessed in a variety of forms. Thermal energy is the energy of an object due to the movement of atoms. The faster the particles move, the higher the thermal energy and the hotter the object. Chemical energy is the potential energy stored in chemical bonds, meaning that when a chemical goes through a reaction, energy is released. Electrical energy refers to work done when electrons change position. In certain scenarios, electrical energy can produce what is called magnetism. Magnetism is a property certain substances have which cause them to pull or repel each other. Nuclear energy is the energy stored in the nucleus of an atom. For nuclear energy to be released, the nucleus of an atom has to either be split in half, this is what we call nuclear fission, or we need to combine the nuclei of two atoms, which is called nuclear fusion. Both fission and fusion are nuclear reactions that produce energy, but the applications are not the same. Fission is the splitting of a heavy, unstable nucleus into two lighter nuclei, and fusion is a process where two light nuclei combine together, releasing a vast amount of energy. Fission is used in nuclear power reactors since it can be controlled, while fusion is not utilized to produce power since the reaction is not easily controlled. Research continues into ways we can harness this fusion, but all the research is still in the experimental stages. Since the beginning of the solar system, the sun has produced its energy by nuclear fusion, and the energy that reaches the Earth, what we call solar energy, is called electromagnetic radiation. Fun fact, nuclear energy is actually one of the cleanest types of energy, and according to extensive risk assessment and matrices, is less likely to cause a catastrophe than fossil fuels. However, past events with outdated technology has created a stigma in the general population, giving people an exaggerated perception of the risk involved in nuclear power. But that's a video for another day. So that's all for this week's lesson. I hope you learned something new and interesting today. If you did find something particularly fascinating, try and teach it to someone else. Whether it's your friends, parents, brothers, sisters, or even your cat, explaining something with confidence, even if it's fake confidence, helps you retain information. Basically, the best way to learn something is to teach it to someone else. If you like this video, please hit that like button and subscribe to the channel. It really does help a lot and ensures that you are notified every time I upload a new video. If you think someone you know would like this video, feel free to share it. And if you want to continue your scientific journey, check out my other videos linked right here. Have a great day.